The photoelectric effect. It did so much for us in the sciencing world that every little thing that the effects concluded could not be explained in a short amount of time. I mean, it revolutionized the way we think about science. It started a brand new branch of science, quantum mechanics. It gave light a new definition. It even won Albert Einstein the Nobel Prize in 1921. The photoelectric effect. So it's described by electrons being ejected from a material when the light hits the material. However, it's not any light. It needs to have a frequency above the threshold frequency of that material. This can be kind of confusing, but it's kind of like saying if we had a ball, which would represent an electron, and the world, which would represent the material's atom. We know if we had enough energy, we could eject the ball from Earth's gravity. This process is basically the same process as the photoelectric effect. But let's say the ball was not given enough energy, and it was unable to get out of Earth's gravity. This would be like if we had a light source that was low frequency, lower than the needed frequency to eject electrons. The needed frequency to reach to get the ball out of Earth's gravity or get the electron out of the material is called the threshold frequency. But what about Einstein? What was his thought process about this? Albert Einstein won the Nobel Prize not for his demo, but his understanding of what the photoelectric effect meant. He knew that light can behave as a wave thanks to the double slit experiment from Thomas Young. However, he knew that his experiments showed that light can behave as a particle. But let's go back to the double slit experiment. This demo involving two splits clearly showing light as a wave. I mean, look at the example of the two waves interacting. How could it not be a wave? But I have another demo with a glow-in-the-dark star. And it glows when electrons are given energy from a light source. Light would have to be a particle to affect another particle, like an electron. So Einstein, what did he do? Light has to be something, can't be nothing. If light behaves as particles in some cases and waves in others, what was the answer? Einstein, I think, gave a great answer. Protons, bundles of both particles and waves. This idea opened the doors to many great things that you know and love today, and answered the questions humanity questioned. Thank you.